Welcome to Shampered. I'm Chesa, and here we discuss all things 3D printing. Today we're looking at modifying an extension cord to go from looking like this to looking like this. Okay, so obviously I cut this end off. It's a regular 14 gauge extension cord, about 3 meters long. We used to use this cord at the dining table to power our tabletop induction stove. And since we're using it so often, I thought maybe we should make it a little more permanent and stick it to the table itself. And the solution I came up with is to use this receptacle with the cable. This product, I've used it in many rooms throughout the house, and I really like it. Why I like this product is kind of besides the point, so I'll skip that. And let's turn it around and look at the 3D printed portion of this project. So it's a regular junction box, surface mounted, and tilted 45 degrees to make it a little bit easier. If it was vertical like this on the table or completely flat, that would be a little awkward and a little inconvenient. So I've opted for a 45-degree tilt. On the back side, I have the cable strain relief, which I clamped down with an M3 insert. Let me zoom in on this. Yeah, so there's the M3 screw on one side, another one on the other side, and threaded inserts. They're not visible, but there's one on each side as well. So that's that. And you'll notice there's a very distinct seam line going down this way. That's because this whole print was done with 2 or 3 wells, I think, overall. Because I'm clamping down this cable here, and also there's another hole, which I'll talk about in a bit. All that to say, yeah, this bottom portion needed a lot more strength. So I made this bottom portion 100% solid. Okay, so what is this bottom hole for? It's for this clamp that was originally for an IKEA desk lamp. So I modeled the inside of this junction box in a way that it works with the clamp. Let's jump on the computer and I'll show you the details. Okay, we're on the computer, and this is how I printed the model. I chose this orientation because it eliminates any supports that I would need if I printed it any other way. So that was nice, and it doesn't compromise the strength down here at the bottom. And like I mentioned, this yellow modifier, I made it so that this portion is 100% solid. Same thing goes for this entire piece. And it's pretty obvious, but just to call it out, the orientation for this clip is also intentional because the pressure when everything is installed is along the Z-axis. If we look on the underside, which is actually the front side of the receptacle, let me actually, yeah, so these holes are all standard dimensions for North American electrical devices. So any receptacle, light switches, they all share the same distances and hole diameters. So I took that from the internet. And a super quick note about the volume of the box. Because it's tilted at 45 degrees, naturally it's going to have a lot more volume because you have this vacant space way in the back. But also I made it kind of spacious, even without the 45-degree tilt, knowing that I like that USB integrated receptacle a lot, which tends to be a little bit larger than quote unquote the dumb devices. So I wanted a little more space there. And here in the back, there's a long groove that is specifically made for that IKEA clamp that I showed earlier. so that it doesn't move around within the box. And the other thing is that because the box is plastic with very smooth bottom surface, and the surface the box is going onto is also very smooth. It's a wood table, but finished in polyurethane, so there's not much friction to hold this in place. So I'm thinking I'm gonna need a small sheet of fabric material that you put under your rug. Yeah, something along that line. And before we end the video, here's a quick look at the sliced model. It's going to need about 126 grams of filament. Going to take about 3.5 hours. So yeah, that wraps up the video. Hope you found this video helpful. Thank you for watching, and I'll see you next time.